Welcome to Steidle Building, the home of material science and engineering here at Penn State. My name is John Paul Maria. I'm a faculty member of our department, and I'd like to take this opportunity to give you a tour of our facilities. We're now in the Steidle atrium on the ground floor. This is a large space that is used by graduate and undergraduate students for studying or just relaxing between classes. It is also event space that is used for different research competitions or for different department and social events. Steidle Building supports the department administrative activities, the undergraduate laboratories and classrooms, as well as graduate laboratories and office spaces. We're now in room 401 Steidle, also known as the Rotunda. It's a room that's used for lectures, for classes, and very often for student dissertations. This frame highlights the historical transition of Steidle from its original 1929 state to the newly remodeled state that was completed in 2016. Behind me, you'll see a large glass wall behind which are about 21,000 square feet of laboratory space that house a large fraction of our department's graduate research. We're currently in the laboratory space on the second floor of Steidle Building in an area that's occupied by the Maria Group. Our group specializes in thin film preparation, and around me you will see and hear a number of instruments that are used to make very thin coatings, primarily but not limited to electronic materials.
My name's Ian Mercer. I'm a first-year grad student in the Maria Group. This right here is atomic force microscopy, or sometimes called AFM. Right now I'm looking at the surface morphology and roughness of aluminum boron nitride ferroelectric thin films.
Magnetron sputtering is one of the most common methods for preparing thin films. This instrument here is a tool that we developed to sputter calcium oxide. Calcium oxide is an interesting host for qubits, which may enable modern quantum computers.
Hi, my name is Darren Pagan. My research group studies the atomic and microscale origins of the mechanical and functional properties of crystalline materials. We do that through combinations of novel in situ characterization, big data analysis, and computational modeling.
Hi, I'm Lutifafaya Odumo. I'm Professor of Material Science and Engineering at Penn State. Welcome to the Dumo Group. Here we focus on materials for device applications. Our focus is more on organic materials, for example, semiconductor polymers, also on hybrid material like metal halide perovskite. We also work on quantum dot for optoelectronic and photovoltaic devices. Our focus is more on the degradation mechanism and the stability of the devices for application in outdoor or indoor environment. We also push more low-cost fabrication, especially in the metal halide perovskite, where we make them in ambient for research accessibility and any other things that we can think about. Yeah.
Hi, I'm Jensen.
And I'm Makita.
We both work in Dr. Rob Hickey's group, and we do a lot of polymer synthesis and polymer physics. So we have a couple projects in hydrogel materials, pre-ceramic polymers, and hybrid polymer ceramic type polymer grafted nanoparticle materials. So we're going to take you on a little tour of our lab space. So here we're in floor 318 of the Steidle Building. It's a community lab space that are shared between a couple of research groups. The Hickey group is kind of right here in this front corner. This entire aisle, as well as that aisle, completely dedicated to fume hoods and benchtop spaces, where we can do kind of wet chemistry and material synthesis and sample prep inside the fume hoods, as well as lots of storage space for our glassware, our supplies, our chemicals, and any samples we create. So we have kind of this whole deep space. Right on these sides, we have kind of the standard sized fume hoods that are basically have the storage cabinets underneath. And as we come down to the next bank of fume hoods, we also have a couple like full-size walk-in fume hoods that reach basically the full height of the human. So in this one specifically, we have a couple pieces set up. On this side, we have just a vacuum drying line for, in this case, a polymer sample being dried so that it can be used for characterization.
And here we have our flask under vacuum that we got rid of all the oxygen for the anhydrous reactions that we wanted to do. And here we're depositing some tetrahydrofuran in it.
Hi everyone, my name is Urara Hasegawa, Assistant Professor of Material Science and Engineering. And my group is developing polymeric material for biomedical applications. And my group synthesizes polymer and develop nanomaterial, evaluate them in biological systems.
Hi, I'm Mary Kate.
Hi, I'm Jacob.
And we're both part of Dr. Susan Sinnott group here at Penn State. As a computational group, we focus on using and developing atomistic scale models and methods to design and investigate materials and their properties.
And more specifically, Mary Kate and I are a part of the Penn State MatSE. So this is across different colleges here at Penn State and other universities where we explore high-entropy oxide systems using these tools.
What we have here is the computationalists will have meetings, we'll discuss research, collaborations, we'll do our own studying, we'll do homework. Really it's just a space to come together and have open discussions about the work that we're doing. As computational students, we're always looking for whiteboards, and luckily in this room, all the walls are whiteboards that we're readily able to use and write on.
Hello and welcome to the SINHA Research Group, where we explore the utility of bio-inspired sequence-defined polymers. And we make these out of various combinations of peptides, peptoids, nucleic acids, and their conjugates to assemble the next generation of biomaterials and nanocomposites. Using high-throughput synthesis and characterization techniques, we screen to identify unique sequence-driven and molecular-driven structure-property relationships that can alleviate material design limitations in healthcare, energy, and sustainability fields.
Hi, I'm Shaylee and I'm a graduate student at Penn State.
Hey, I'm Jess and I'm also a graduate student at Penn State.
And we're part of the Morrow Group. The Morrow Glass Group works on a very diverse set of research, all related to glass, but we also work on glass coatings, on glass ceramics, computations and simulations of glass.
We also work on fundamental structure property relationships of glass, working on making glass more sustainable for a more environmentally friendly future, and we work on things that are very specific applications like glass bottles or bioactive glasses.